There we go. Boop, boop. All right. So Griffin, let me go and look at what we did. Okay. So we talked about the ellipse and how the parametric functions, when they are vector valued functions, show us the direction. We talked about vector valued functions and operations we could do with them. And derivatives of the vector valued functions. And then we did the dot product, which wasn't awful. And then we spent the rest of the time doing the cross product. And then I looked at the curriculum and realized, oh hey, we don't actually need to do the cross product. So we spent all that time suffering for no reason. But hey, you know how to do the cross product of vectors now. Or you've at least seen it. I don't expect you to have mastery. Um, I mean, I could, but also the complete notes are on the eCampus. I can go over the essential stuff again. Like the stuff that you actually need to be able to do. Okay. That's fine. I'm looking at the Khan Academy to see what they have on here in terms of the vector valued functions. Yeah. Why are you sitting outside? Did they close and kick you out? It's only like 8:04. Caitlin, do you have additional questions you want me to do? Number 19. Griffin, go inside the Starbucks. Get yourself a hot drink. Alright, number 19. If the natural log of y. Okay, but you have to wear Uggs if you go get a PSL. Alright, so this is another logarithmic differentiation, except it's backwards. So you can look at it and you'll be like, okay, dy dx, I can use implicit differentiation. That's a thing I know how to do. But you see a natural log on both sides. Let's raise both sides to e. So when I say raise, I mean like bump it up. So e natural log y equal to e x squared natural log of x. So e natural log of y is just y, and then e to the x squared natural log x is e to the x squared times e to the natural log of x, and then there's e to the x squared times x. So now this is a much nicer function to derive. And if you look, well, bam, we're already in terms of x. Now all we have to do is take the derivative. So dy dx is equal to first, and then d second is e to the x squared multiplied by the derivative of x squared, which is 2x, plus second, d first is just 1. And we could stop there, but they go further. Oh, I didn't read the whole problem in terms of x and y. Oh, I hate it when I cut myself off. Okay. I wonder if I can anticipate what the answer will be. No. Alright. Scratch all of that. Oh, alright. What is dy dx in terms of x and y? So now we're just going to take the derivative of both sides, the same way that we did before. So the derivative of the natural log of y is 1 over y dy dx, and it equals 2x natural log of x plus x squared 1 over x. So this is just the simple differentiation rather than the complicatedness I was trying to make it. So we're going to have 1 over y multiplied by dy over dx equal to 2x natural log of x plus x. And we're going to multiply both sides by y. So we have 2x natural log of x plus x being what dy dx equals. And this isn't any of the answer choices right now, but if we factor the x out, we have 2 natural log of x plus x, which is answer choice A. Yeah, love making mistakes. Makes me feel so good. Like warm and fuzzy inside. The complete opposite of what Griffin is feeling. You good? Good. All right. Huh? Did I read 14 wrong too? I'll do 22. I'm just checking my work for a second. I did 14 wrong. So we did like all of the steps right. Yeah, the 15 over 4 is definitely bigger than 5 over 4. Yeah. So instead of this being C, it is B, because 15 over 4 is greater than 5 over 4. Alright, so 22, right? Okay. Ooh, average value. That's an integral. And it's going to be answer choice D based on my gut right off the bat, but that's wrong because that's how they get you. Unless I'm looking at 23 and not 22, and 22 does say answer choice D. Okay. Alright, you did want 22, right? Okay. So, we want the average value of f of x equal to this in this, right? Now, the average value of a function over an interval is given by, I'm going to increase the size of that real quick, is 1 over b minus a on the interval from a to b, not b to a. Hello, will you erase, please? Thank you. A to b. All right. Of f of x dx. All right. So just based off this, I'm looking at the answer choices and this part in particular. And the only answer choice that has that true with the function on the inside and the proper bounds is answer choice D. Did y'all not get that last year, or is it just rusty? Rusty, okay. Now what? Let's keep chugging along. Got only another 44 minutes. Alright, 29 and 30, and then you're good on the multiple choice, you think. Oh. 29? Did you just look at 29 and get overwhelmed, or what happened? Okay, because this one is just finding the derivative implicitly and solving for dy dx. And then 30 is another optimization question. You still want me to do these? Since you haven't actually tried, or do you want to try them? Okay, you try it really quick, and I will do my own thing for a little bit. Let me know when you have your solution. $29 is not B, unfortunately. It is A. So let me work it out. So 2x plus x dy dx plus y plus 3y squared dy dx equals 2 plus dy dx. Yeah. So now I'm going to try to gather all of my dy dx's on one side and all of my terms that don't have dy dx on the other. Oh, just derive it as it is. It doesn't matter. Just find the derivative part first and then move it around from there. Because you're more likely to make a mistake in moving the y's over first and then deriving, rather than deriving first and then moving. The way that has more mistakes, or the way that I recommend not doing. Gotcha. So now that we have it isolated, I'm going to factor out the dy dx. So I'll have 1 minus 3y squared minus x. And then from here, we just need to divide both sides by the blue part. So 1 minus 3y squared minus x is equal to dy dx. And all of their answer choices start off with a positive 2 in front. So I'm going to factor a negative out of the top, and the denominator starts off with just the x, so I'm going to factor out another negative from the bottom. So I'll have 2 minus x minus y and x plus 3y squared minus 1 equals dy dx. The negatives will cancel, and then we will get an answer of 2 minus 2x minus y over x plus 3y squared minus 1 equaling the dy dx. So they all have that positive 2. They all subtract the 2x, but only answer choice A subtracts the y in the numerator. You retried it as I did it with the less mistakes, and did you get it, or did you make another mistake? Okay. Good. So, 30. Do you need help, or do you want me to give you another minute to try that? Okay. So with 30, it says we want to find the point on the graph of y equals the square root of x that is closest to the point 1, 0. And to do that, we're going to want to minimize the distance. And the distance formula, it's been a minute, so I'm going to just write it out, is going to be the x2 minus x1 squared plus y2 minus y1 squared. Now, this is going to be our x1, y1. Alright, so x1 and y1 are going to be those. And then the x2 will just be x, and the y2 will be our function, or what y equals, or what f of x equals. Okay, so we're going to want to minimize this distance formula. So let's start off by plugging in all of our stuff. So we're going to have x minus 1 squared plus the square root of x, because that's what y equals, minus the y1 was 0. Okay. Now we're going to clean this up a bit. The x minus 1 squared gives us x squared minus 2x plus 1. And the square root of x minus 0 is the square root of x. Square it, and we get plus x. Okay, I'm only just now seeing your question about why is the function plugged in as y2. And that's because the second point that we're interested in is the point x, f of x. In other words, for what x value plugged into the function, what y value do we get out? And that set of coordinates is given to us by putting our independent variable inside the function to pop out the dependent variable, or the dependent value. Okay, so you're good to here now, right? Yeah, alright. So then we clean this up, and we have x squared minus x plus 1 is equal to the d. And we need to take the derivative of this. And this will be one of the few times where you see me just do d prime instead of the derivative notation. And I do that because seeing d dx is confusing, or will be confusing for a lot of students. So this is the one time you'll see me do a prime. Otherwise, I prefer to do the implicit notation. So we're going to do the power rule with this radical, because the radical is the square root, so that means we're at a 1/2 power. We bring that 1/2 power in front. And then we're going to subtract 1 from the power, so we're going to end up with negative 1/2. Then we need to take the derivative of the guts. So it's 2x minus 1 is the derivative of those guts. And if we clean it up, we'll have 2x minus 1 over 2, and then the square root of x squared minus x plus 1. Now, since x squared is always greater than or equal to x, the quantity x squared minus x is always going to be greater than or equal to 0. And x squared minus x is always going to, x squared minus x is always going to, plus the 1 is always going to be greater than or equal to 1, meaning our square root is never imaginary. So there's no critical points that we get from the denominator equaling to 0. But if we do our numerator equaling to 0, we get that x is equal to 1/2. Alright? And then because our original function was y equals the square root of x, we need x to be strictly greater than 0. And 1/2 is greater than 0, so we're good. So, because we only have the one critical point that's inside our domain, and none of the above is not an answer choice, this tells us that the correct answer is B, because x equals 1/2, so we're looking for 1/2, and then whatever the f of 1/2 is. And the only answer choice that has the 1/2 in the x-coordinate is answer choice B. What do you mean it got gross towards the end? This was just telling you this part, because we needed to know if that was a critical point or not. Alright, less than 30 minutes. What else we got? Oh, sorry, I'm only just seeing your question. You totally understand up to the derivative of d, but then the actual number is a little weird. What, are you talking about the y value? Oh, well, getting the coordinates is you take this x equals 1/2, and then y equals the square root of 1/2, which is equal to the square root of 1 over the square root of 2, which is equal to 1 over the square root of 2. But that's not what you meant by getting to the coordinates in general. You're talking about when I first had the coordinates up here? What's in orange? What's in orange here? Oh, well, this is just me saying that x squared is always bigger than x. So if you take the difference of them, it's always going to be 0 or bigger. This part here. This is just a mini proof that x squared minus x plus 1 is always greater than 0. Or always, yeah, greater than or equal to 1. Any better? Or is that part still a little nasty? Or weird? You said weird. Yeah. So the denominator is just never undefined, so there's no point that I need to test there. And how did I get the 1/2 specifically? This part, right here. If 2x minus 1 is equal to 0, then x has to equal 1/2. Do you need me to show you the algebra behind that? Yeah. Well, we were trying to optimize it, not necessarily the max, but yeah. You need to find where the derivative equals 0 or the derivative's undefined. Yeah, so the numerator is when it's equal to 0, and the denominator is when it would give us undefined. And since the denominator is never equal to 0 or non-existent, then we don't need to care about it. There's no points that come out of it that we need to test to make sure that we're choosing the optimum point. And there's only the one point that comes out the numerator, so that's got to be the value we use. How do you feel about the problem now? You 80% get it. Is the other 20% just the practice of it? Probably. Okay, that's fair. Is it only you in here, or is there other people? Are there other people? And there are two other. Okay. So I bet that's Jason. And is Griffin in here still, or did he get his PSL and go away? Which would be sad. But at least he'd be warm with a PSL. I don't know. I can't actually see who's in here and who's not, so I'm just kind of milling about, seeing if they'll say that they're in here or not. We'll give it another few seconds. Okay. So, do you want me to find another problem like this that we can solve out? Or do you have other questions that you would rather work on? Okay, so you're fine for now? You don't have anything else you want to do? Okay. Well, have a good night. I'm gonna send out a little remind message letting everyone else know that there's only 17 minutes left. Hello. There's only a few minutes left, so I'm just here if you have any questions. Because remember, there's no video games, so this is it. Do you have any questions, or are you just here to see what the stream is like? Jason. Divide where? Oh, A plus B equals A. Okay. And then 2A equals A. I'm not sure what you do from here. Like, why are your plus ones? Okay, so 3 is equal to 2. And then add 2 to both sides. So 5 is equal to 4. Okay. Okay. So is that all the math for this proof you've got? Geometry doesn't know we do streams. And I won't tell them because I'm not going to have them infringe upon calculus time. But also, this part and this part causes problems. Oh, wait. No. I read that wrong. I'm on the wrong side of the equation. Yeah, because that's 0, technically. There you go. Anything else or not so much? 2 minutes. Yes, 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 yes. That better not be the same potato video you sent me before.